Okay, I'm gonna go over 10.5, number 22 in 10.5, number 25 from 10.6, and number 27 from 10.6. So we'll start with 10.5, number 22. So we have triangle MIA, and then this line here, LN 2 and 1. Okay, so we're given triangle MIA with, that's an M, MI equals IA, and LN equals NA. So, like all proofs, we are going to start with the given, and we're going to find as much information from the given as possible, and then we'll move on to the next given, because we're given two things in this proof, and then we're going to piece it all together. So, we start off with MI equaling IA and LN equals NA. This is given. So one thing we can do is we'll take MI equals IA, and the thing we're trying to prove that these two triangles are similar. So what we want to do is we want to find proportional sides and an equal angle, or two equal angles. So that's what we're looking for. Right now we're given a lot of stuff about sides, so we're probably going to try and find proportional sides to begin with. So I'm going to take MI equals IA, and I know that if I divide one side by something, we have to divide it equally on the other side. And since LN equals NA, I can divide MI by LN, and I can divide IA by NA. So that is what I'm going to do. Goes IA, NA. And it's still equal because we're dividing by the same thing. And this is just division. From here, I can't really find out any more information. So what I'm going to do next is I'm going to move on to my second given. My second given is angle I equals angle 1. This is given. And so that is all I need to know, because I have a side, and an angle. If I look over here, MI and IA, so MI and IA has angle I in between them, and LN and NA has angle 1 in between them. So I know that this is going to work. Triangle MIA is similar to triangle ANL, or LNA, sorry. By side, angle, side, similarity. So again, what I did is I looked at, are we looking at sides? So the first given, we're looking at sides, so I want to try and find proportional sides, so that's what I did. Next, I was given an angle, and then I just pieced it all together. We will look at 10.6, number 25 now. This one's a little more tricky. It's a little more tricky, but it's also doable. So we are given that UE bisects angle U. But we can't just say angle U, we have to say angle D, U, P to specify, because right now we have 1, 2, 3 angles there, so we need to be specific on which one we're talking about. And we're also given NE parallel to UR. So again, we start with the given, or the first given. We're going to work our way down. Once we hit a roadblock, then we're going to move on. So we're talking about bisecting angles, so we're probably going to use the bisecting angle theorem. So I'm going to start with UE bisects angle DUP, and this is given. So again, we want to use the angle bisector theorem because we have a bisecting angle. So we are going to say that DE over ER equals DU over UR. Bisecting angle theorem. So this line here is bisecting, so DE and DU are proportional to E. Oh, this is supposed to be an R. ER and UR. So this is proportional to this, and this is proportional to this. And we know that this angle is equal to this angle. But we can't use this side angle side theorem unless we know that this angle is equal to this angle. So again, we've hit a roadblock, so let's move on to the next theorem. So NE, or next given, NE is parallel to UR. So NE right here is parallel to UR. And what this should remind you of is the side splitter theorem. So the side splitter theorem will give us that dN over NU is equal to dE over ER. So dN and dE are proportional to NU and ER. So again, we get that from the side splitter theorem. Oh, sorry, given. Side splitter theorem. All right, and now we see that they both. Just a second. DE. Sorry. They both share this one. That's what it is. So that means we can set these two equal to each other, or we can just sub this in for here. So dN over NU equals du over UR. And that is what we were trying to prove, and we use substitution for that. Okay, last one here is number 27 from 10.6. This one's really tricky. So it's okay if we didn't get it on our first try, but it's a good method to know. So we have H, E, B, N, I, and D in the middle here. Okay, so we are given that it is isosceles. BHI, BH equals BI, right, with BH equal BI. We are also given HN bisects angle BHI, and IE bisects BIH. Okay, so again, start with the first one. So BH equals BI in the isosceles triangle BHI. So we're given this one. Our natural instinct is to look at the angles after this. So let's just, might as well just do it. So angle BHI equals angle BIH. This is theorem, I can't remember the number, but angles opposite equal sides are equal. So we've done all we can for that, so let's move on to the next given, which is HN bisects BHI and IE bisects angle BIH, and that is given. Okay, so again, we are dealing with bisecting and trying to show triangles similar, so we are probably going to use the bisector theorem for this one. So based off of this, we know that BN over NI equals BH over HI. And so that's for this one. And for this one, we are told that BE over EH equals BI over HI. This is the angle bisector theorem. Okay, so from here, this is all we really need to know in order to accomplish our goal. In your corrections, they did not put this step in here, but I think it's pretty important to solving it. So because we know the angles that are being bisected, because we know that those angles are equal, we actually know that this ratio here, or this proportion, is equal to this proportion because it's the same angles being bisected, so the same proportions will apply to each one, if that makes any sense. So we can actually just substitute, so we're going to take this one and we're going to substitute BH over HI. So BE over EH will equal BH over HI. And then from there we can substitute BE over EH is equal to BN over NI. So you know, because the angle bisector theorem, you know that this right here equal to this. So that's why we can substitute that in. And then from there, since this, let's change it up. This is equal to this, we can sub it in for here. And I, that's an I. So that's how we find that one out.